My name's Mark. I'm a 4 times tech founder, and I'm a 4 times national chess champion. So welcome to this episode of Software Endgame. And just as a reminder, last week we spoke about a move towards decentralized applications, as opposed to using services like AWS in the cloud to build server-based systems, decentralized peer-to-peer, and that type of thing. So we all know that AWS is a real success story in the Amazon brand. They've built services that help Amazon run all of its companies, and they've opened up to the public over the last couple of decades. And now so many people in the world are building services and their applications using AWS. And they offer something for everyone. They help you with your different database types, data lakes, AI, even IoT devices, so many things. So it just really makes life easier for startups and companies trying to build new systems. And so the question that we have to ask is, why would anybody not want to use AWS? I mean, you'd have to be crazy to move away from that. So with that note, I'd like to say welcome to my guest today, Kevin Puri, who's the CTO of PrivacySeal. So PrivacySeal allows you to instantly authenticate people, companies, documents, and so it makes it easy to work with the unknown. So Kevin, maybe you can start out by just telling us a bit more about PrivacySeal and what it's all about.
But thanks for inviting me. I think this is a really fascinating topic. It's very, very close to my heart, and has been for many years. And it's just great to see the sort of culmination of a lot of emerging technologies that are actually enabling this as a reality now, which is fantastic. So it's definitely a crazy world. And, I certainly wouldn't be advocating everybody to sort of jump onto the P2P, decentralized bandwagon. I think there's a lot of value in it, but I think that, once again, all these problems are hard. They're difficult. There's no easy way to go about it. On AWS, us doing quite large Kubernetes deployments, doing multi-tenant, globally distributed systems. That's hard. It's not easy, and getting peer-to-peer systems to work properly, once again, is hard. It's not easy. But I think I've always been drawn to the decentralized world. I think I posted my first, decentralize all the things meme about a decade ago. So I've been, the beginnings of Bitcoin, that kind of thing, when the community was emerging, and there was this sort of drive, even then, 10 years ago, to start getting away from centralization and into more, in inverted commas, democratized decentralization. It's we eventually got to a point. So why would we, after putting all this effort and time into getting our Kubernetes clusters up and running, and they run very well, I must say. I'm not here to bash any technologies at all. I mean, I think our system right now works well for its current design, but our specific use case does lend itself to more of a peer-to-peer system. So we've been experimenting off and on for the last couple of years, I think, with moving in that direction. There's also in our space, there's a technology called Verifiable Credentials, which is also maturing now. There's a W3C standard that's about to be rubber stamped, or in fact, I think it's it has been rubber stamped now, just being ratified and everything. So that's the principles behind verifiable credentials have a lot to do with decentralization as well, and pushing the power. And this is an important thing. It pushes the power back into the hands of the user. So in our case, that's the holder of the credential. So it's very important to us that the holder of the credential owns, controls, and has full authority over their credentials, which is a bit of a flip around, because at the moment we have these issuer groups that have full control over other people's credentials, and basically everybody has to sort of go hand in hand, please can I have my credential, whatever that may be. Credentials also a very wide thing. It's in our case, it's normally more to do with some kind of membership or certification or degrees or those kinds of things. But a credential can be almost anything. It's a credit card, a driving license, a passport, all that kind of stuff is also a credential that refers it relates directly to your identity.
Can I ask you a question on that? So, if you're decentralizing the storage of the credential, because it sounds like there are companies that hold your credentials hostage in a way, and you have to work around them. And if they were hacked, and all of it's happened so many times that people get hacked, and then those credentials are distributed. Like, people have lost their social security numbers numerous times. I have. It's a big worry. But if people are holding it themselves because you have a decentralized system, where exactly does the data live?
That's a very good point, and it's something that we struggled with a lot in the beginning, and we haven't quite, we haven't 100% solved either. But one of the technologies that we rest heavily on is there's two main ones. There's Crdts, which are conflict-free replicated data types, which is an extremely interesting concept. It's basically data types that can be that can diverge and merge with mathematical certainty, which is a very nice thing. It allows for eventual consistency, real eventual consistency to happen over a distributed network of nodes. So we use that for a lot of the data, mostly configuration data, that kind of thing. And then we use IPFS, the Interplanetary File System, which is also a distributed system. It's a fantastic system. It's quite amazing.
We actually mentioned that. We actually mentioned that in our previous session. We just ran through that a little bit to show that you can have a peer-to-peer distributed document model that can break up, operate across many computers, and reassemble as needed.
Yeah, and it's fantastic because, especially in our use case, content-based addressing, with a CID, a content ID, is fantastic, because every certificate or seal or whatever we generate as an asset and publish and we put onto IPFS, is already cryptographically verifiable, which is amazing, because that's exactly what we need, is verifiable, credential, to make sure it hasn't been tampered with, et cetera, and you literally get that out of the box with IPFS just by storing it in there. It gets more complicated because of,
isn't there a danger that if you're storing, IPFS in a way is public, unless you've encrypted the documents. So couldn't somebody sneak in and find data if it's public? How do you avoid that?
Well, there's two approaches that we're actually busy testing, and the one is you can have a private IPFS network, but it just doesn't sit well with me. I'm kind of the point of decentralization is to open up to the world. So what we're trying to do more is lean more on cryptography, and specifically at the moment, public key infrastructure cryptography, private public key stuff. And what we do is we actually encrypt the asset before storing it in IPFS, and then the nodes have a way of, because it's sort of like a chain. We do some quite funky stuff with the public key infrastructure stuff, and any of the nodes below a certain branch in the tree can decrypt that asset. So that can provide a lot of security. The other thing is that not all of our credentials, need to be private. In fact, the majority don't. It's people are putting it, they want it to be exposed. It's if you have your degree, you actually want people to see that. Well, most people do anyway. So
yes.
So it's kind of in our case, it's not such a huge thing, but just by default, we take the approach of maximum privacy. So we're trying to implement that as well.
Okay. So obviously there's managing your data in a distributed, decentralized fashion, but you also need to, I mean, somewhere there has to be processing of things. Like there have to be workflows, there have to be some kind of business logic that lives somewhere. Where does it currently live, and where would you like it to live in the future?
Well, the current system is a very classic. We have our sort of our APIs, our models. We have central database. That kind of it's a classic architecture. But as we move towards the peer-to-peer world, each of our agents has to be very intelligent. So it's we push off the intelligence into the actual agent itself, and that's been quite a challenge, but it's also been very nice because it's made a lot of things we want to accomplish actually simpler in the long run, because we can rely on the agent's intelligence to solve problems that can come up without our knowledge.
Right.
Whereas in the classic AWS system, or at least with the API front end, back end, that kind of system, if something goes wrong, everybody's affected.
Yeah.
Whereas with the decentralized system, it's much more organically robust, and it'll keep on going. And that's the 100% high availability is our goal. People rely. We do a lot of regulatory certificates as well. So if someone's doing a tender or something like that, and it's an urgent thing, they need to have access to that certificate. They can't not be able to get it. So we have to, we can't go down. It's a very important thing. So that I will sleep a whole lot better at night knowing that agents are intelligent enough to sort themselves out and provide a certificate than worrying whether the whole AWS region is going to go down or not.
So I'm just going to dive a little bit into what is the definition of an agent for people that don't know what an agent is. So what is an agent? Where does it live, and where does its processing live?
Well, the agent, there is a sort of classic, computer science definition of the agent, but in our case, it really is just an intelligent node that has an identity. So it's I almost sort of prefer to call it a node in our terminology, because we do follow sort of the agent and sort of meshed in with that the actor kind of model of a sort of self-sovereign thing that is able to make its own decisions about how it's going to process things. So it's more about that. It's like it has agency. It's the thing that actually it's not dumb. It's capable of making decisions on its own. Yeah.
Right. So it could live anywhere and just be operating wherever it is. If you use the word actor, you obviously, I do know that you built your system in Elixir and Erlang. So you're obviously looking at the actor model operating on the Erlang ecosystem. The one benefit, obviously, from an Erlang environment is that you can build in some form of self-healing when things go wrong, it goes down, and it boots itself up again. How does that work within the environment?
Just once again, really love Elixir and the whole environment, because it's you just get that for free, on the Erlang VM. So it's kind of we make, and it also once again lends itself to running literally millions of processes, on relatively small amounts of hardware, and reliably, and like you said, with self-healing, the sort of supervisor strategy of the Erlang VM and sort of extended by Elixir is quite amazing, and it's very, very robust. It's very observable. That's the other thing that's important, is that we, monitoring, et cetera, is super important. and then just self-healing. I mean, we take the just let it crash paradigm very seriously, because we'd rather you can't figure out everything, especially the amount of data and the junk data that we have to deal with, because we're basically getting data fed to us from third parties, a lot of third parties, and at least 20% of that is absolute rubbish, and we just kind of if something bad comes in and the process crashes, then so be it. The rest, it just spawns a new one, and the other 10 carry on, or the other 100 carry on.
Yeah.
So,
I mean, it's interesting because I mean, in my previous companies where we built with Java, we had a policy of don't ever let it crash. But there was a lot of work. We had to do a lot of work to try and make that happen. And when it did happen, it caused big problems. So it's quite refreshing in the Elixir world and Erlang world that you can just say, let it crash. We'll heal it afterwards. It's very lightweight to do that.
Yeah, exactly. It's great.
So I mean, you have these nodes which run autonomously. They manage themselves. They have their own processing. What happens if somebody tries to spoof an agent on a node and tries to do some damage? How do you manage the security of rogue agents coming in and doing weird stuff?
Yeah, that's obviously a very big one, and we basically just take a leaf out of Bitcoin's book there, or at least any kind of blockchain, and we basically we just exclude it from the network. So if we detect any anomalies or any sort of, and also the whole thing is that even though we're running on this public network, we still use a lot of cryptography. In fact, we use cryptography everywhere. So it's almost like a massive private network within the whole system. So someone without keys at a certain level of the tree, of the Merkle tree, won't be able to get in anyway. So it's but if the problem is, and there's two things. If one of those gets hijacked because it can, or hacked, and it has the keys, and the other is if we push, like you said, a rogue agent, if one of them goes bad because it doesn't update properly, or something happens, we need to be able to detect that anomaly. So we have the nodes themselves are sort of doing their own little monitoring system, and if they see one of their friends doing a bad thing, they sort of put their hands up and maybe ask a friend agent, can you see that guy also doing that bad thing, etc., etc. And then if it comes to a certain quorum, then drop that node from the network.
Right.
Yeah.
Okay. Interesting. So the one project that we spoke about in last week's episode was Project Lumen, which is part of the Elixir community. They're building this project. And Project Lumen, I mean, we've spoken about this previously, and we've spoken to some of the people on the team. But what they're doing is they're actually building a new way to convert Elixir Erlang code into to run on LLVM, which means it doesn't even need to use the Beam, which is the Erlang VM, and that has implications, because it means you can build systems in languages like Elixir, and in our case, in my company Trixta, which is built on Elixir, we can actually build software which then compiles down and operates on LLVM rather than Beam. I mean, it's quite fascinating, and I'd love to know what thoughts you have, if that's a technology you're looking at now in your company, and if you did, what value would it bring you?
Yeah, I mean, Lumen is to me one of the most exciting projects on the horizon at the moment. Like I said, I really love the Elixir environment, and I was actually we were sort of moving more and more towards this world where we would have to do Rust and basically, or even C. What I'm saying is that if we wanted to run on certain devices, etc., we just couldn't. We'd have to look at those other languages. But now Lumen, especially running on an LLVM, is opening up that entire world to using that same code on those devices. So it's extremely exciting to me. I think one of the things, and we actually have done, a bit of experimentation with that. The one thing is that the initial sort of knee jerk was, oh, we can just sort of like run our code, in the browser or something like that. It's like, and it's sort of, we realized, well, no, we have to change our way of thinking now, because that's actually a node device now. And, it actually can be very thin and small. We don't need all this infrastructure that we had. So it's opened our eyes up to having small agents running where Lumen can run, in the browser and on devices, on IoT devices and that kind of thing. Small footprint, very sort of task oriented, and perfect for the agent world. That's the thing. It's the ideal is to have an agent running, in the browser on the Raspberry Pi or whatever it is. So
if you run, I mean, I'm not sure where Project Lumen is, so you can tell us how far it's gone. But once it achieves a certain, capability and growth, if you were to run some agent in a browser, and it runs it in WebAssembly, are there risks that if it's running on that local machine that could be, I don't know, interrupted or hacked in some way, or is it safer than normal? I mean, is it easier or safer? Is it worse? Are there other complications to think about?
I think it would fall into the same category as JavaScript at the moment. It's kind of it's a different mechanism for for interacting. Still with the same DOM elements, etc. If it's in a browser and that kind of thing. I think it's just at a lower level. I mean, this is probably controversial, but I would trust, WebAssembly running in the browser far more than I would a JavaScript random thing. I just think that there's the potential for far more safeguards, using on the WebAssembly side than the free, or once again controversial, the free-for-all of JavaScript on the browser on the other side. So but once again, the browser, the browser vendors are doing a lot in terms of security and privacy and stuff like that. So I think the way that things are sandboxed now, and the sort of separation of privileges, etc., makes it very difficult to to actually get any foothold through a modern browser.
Yeah, and I mean, in last week's episode, I gave the example of Silicon Valley, where the team actually developed a system where they hacked into some smart fridges, and then it was Pied Piper who was the actual startup, and they were almost at a loss, but they hacked into these fridges. Then they managed to take over 10,000 smart fridges, and they actually had agents and nodes running on each fridge. Do you think that's feasible at all, or do you think that it's possible? I mean, maybe with Project Lumen and others, to have permissioned use of third-party hardware. So in that case, they hacked in and they actually took control. But like, say that it was allowed, and those fridges actually had ways where they could charge us more fee to use their processing. Do you see that as something that might happen in the future?
I think it's possible. I mean, I think it would be fun. but I think, I mean, it definitely, there might be a few more hoops to jump through to get Lumen actually running on a fridge than just installing it. But it's I think it's it's a fascinating concept though, because that's even just that for manufacturers, etc., to be able to use a nice user-friendly functional language like Elixir to make your fridge work, I think is fantastic. It's sort of it's moving. It's using a nice high level. A lot of that stuff I don't know if it's still sort of control systems level stuff, but it's, C and even assembly is like, you don't have to use that anymore. You can use a high level functional language on your fridge, which is amazing.
Yeah. I just saw a few days ago, Joseph Valle, he was the inventor of the Elixir language. He's been working on the secret project where they now can do machine learning using Elixir. And and what's interesting is some of the optimizations are that they try not move data around too much, because moving big amounts of data around actually slows down processing if you're trying to do AI and machine learning and that type of thing. But in a way, I mean, it makes a lot of sense that we start to distribute AI processing. Whether you're building models, whether you're using models, it should be in place rather than trying to move massive amounts of data into a central server to operate. So have you played with that idea at all, and do you see that as something that you would be interested in?
I'll definitely be interested in it, but I haven't actually given it any thought, because it just literally wasn't possible at the time. It's now becoming possible. It's super exciting to be able to do distributed processing, along with data, et cetera. You're getting to the realms of, the Ethereums and that kind of thing. Not quite, but it's it opens up a lot of doors. It's then it's almost, it would change the way I think about the node architecture, and if you'd almost see this thing as it's like one global app running, which is picking up resources as it can, and executing instructions extremely quickly, because of its size. That would be quite amazing.
Yeah.
But no, I haven't experimented or looked into that yet. No.
Yeah. So one last question that I wanted to ask, and then if there are questions from the floor, we can open up the queue. So at Trixta, where I'm the CEO and founder, we spend a lot of time thinking about how do you build decentralized systems. And what we've realized early on is that it gets quite complicated to build large, distributed systems that are decentralized. And you're a very technical person, so you could hold everything in your head and do everything. But sometimes you work with business people. But if you're working with business people, they have an idea of what they want to build, and there's a traditional way to kind of capture what they want and then actually build that. And it's quite well established in the non-central, in the centralized approach of doing things. We spend a lot of time trying to have very simple tools, visual tools, even using like natural language processing to pick up the needs of the business person and then translate them into something that could be almost automatically built into this complex system of agents and nodes. And what is your experience with that problem? And do you think that'll actually, if we can't find ways to work easily with people that have ideas of how to build a system, sorry, dogs are barking. The actual capturing of that intent from the business people and the business thinkers, and actually translating that into many different node systems and having them interoperate together, it starts getting very complex. So, obviously at Trixta, we're trying to solve that with visual tooling. How do you think the world sees that problem, and will it inhibit the growth of decentralized systems?
No, in fact, I think it might. I think it'll enhance it really, because I think. Sort of obviously with Trixta, the sort of low code and no code movement is growing, in popularity, and I think specifically because business requirements, need to be defined by people who have no knowledge of the implementation and technical side of things, like you were saying, and I think the intelligence that you can build into a decentralized system would adapt far more easily to that kind of scenario. In fact, I think Trixta almost it does it already. I think knowing a bit about the internals of Trixta, it's an extremely good platform for a low code, no code solution, because it has the intelligence built into the spaces, etc. To be able to once again, robustly ensure that the workflows are executed, but also design those workflows in a way that you don't have to be a, propeller head techie, so, bottom line is I actually think decentralization would make that far more approachable.
Right. Cool. And thanks, Kevin. It was really interesting. I'm looking forward to seeing more of your application as it rolls out. And it is a fascinating topic to think about decentralizing away from a central server and looking at ways to distribute data and processes. I think it's just the beginning. I mean, people have recognized it throughout, well, the last decades actually. But my assumption is that it will become mainstream in the next decade or two. So you're obviously on the frontier. Yeah,
I hope it does, and I think it's the right time. The time is now for it to happen. And I mean, and the thing is, people must just realize it's fun. I'm having so much fun again. It's unbelievable. So
that's great.
Get involved.
Totally. Yeah, and just one last question. Do you have an open source aspect to your business that people could find and look at?
Not yet, but that's we from probably mid June, July this year, we were wanting to open up pretty much all our code.
Okay.
Because once again, we feel it's extremely important from a security and privacy perspective that there's validation of the code. So that it will be coming. Just don't know when. It's
that's fine. Yeah, so we will take this video stream and put it on YouTube at some point, maybe some other places. And once we have that, we'll add that below the video. And potentially down the line, we can speak to you in the future as well as things have progressed.
Thanks, Mark. I'd love to. Yeah, that would be great.
Absolutely. Thanks, Kevin. It was great chatting to you.
Thanks, Mark.
Speak to you soon.
You too.
Take care.
Yeah, keep well. Cheers.